This video is a basic geometry review for those who are taking the SAT or the ACT exam. And if you're taking a geometry final exam, you could benefit from this video too. So let's go over some common shapes and the formulas that you need to know. So let's say if we have a circle. I know my drawing is not that great, but let's work with it. And let's say that the radius of the circle is 5. Given the radius, what is the circumference of the circle, and also what is the area? The first formula you need to know, the circumference is 2 pi r. So therefore, it's going to be 2 pi times 5, which is 10 pi. So that's the exact answer. Sometimes you may need to put this in your calculator and get a decimal value. So you could use the fact that pi is about 3.1416. So this is going to be 31.416. So that's the circumference. Now what is the equation for the area of a circle? The area of a circle is pi r squared. So for this particular example, it's pi times 5 squared. 5 squared is 25, so the area is 25 pi. So 25 times pi, I'm going to use the exact value. As a decimal, that's 78.54. Now what about the diameter? If you know the radius of the circle, what is the diameter? So the radius is between the center of the circle and it touches any point on the circle. That's the radius. The diameter also passes through the center of the circle, but it's a distance from one edge of the circle all the way to the other edge, and it always has to pass through the center of the circle. If you have a line that touches 2 points in the circle but doesn't pass through the circle, the center of the circle that is, it's a chord. So this line, it touches these 2 points on the circle, but it doesn't pass the center of the circle, so that makes it a chord. But a diameter is between 2 points on the edge of the circle, and the diameter passes through the center of the circle. So make sure you know the difference between the diameter and the chord. The diameter is twice the value of the radius. It's 2r. So in this case, 2 times 5 is 10. So for a circle, these are the three main equations you need to know. The circumference, 2 pi r, the area, pi r squared, and the diameter is twice the length of the radius. Now the next shape that we're going to talk about is the square. So let's say that the side length of the square is 8. What is the area and what is the perimeter of the square? The area of a square is basically side squared. All sides of the square are the same. So in this case, S is 8. So the area is just going to be 8 squared, which is 64 square units. Now to find the perimeter is the sum of the four sides. It's S plus S plus S plus S. If you add S 4 times, it's the same as 4 times S. So the perimeter is 4 times 8, so it's 32 units long. So make sure you know those two equations for a square. The area is side squared. The perimeter is simply the sum of all four sides, or 4s. Now here's a question for you. Going back to the square, let's say the area is 36 square feet. What is the perimeter of the square? So we know that the area is s squared. By the way, for each of these questions, pause the video and see if you can figure it out. So the area is 36. If we take the square root of both sides, we can get the length of each side. So each side is 6 units long. Therefore, the perimeter is 6 plus 6 plus 6 plus 6 4 times, or 4 times 6. So it's 24 feet long. That's the perimeter. Now going back to the circle, let's say if we're given the circumference of the circle. Let's say the circumference is 16 pi. With this information, find the length of the diameter and also the area of the circle. So first, we need to find the radius. We know that the circumference is 2 pi r, and the circumference is 16 pi. So what we need to do is divide both sides by 2 pi. So 2 pi divided by 2 pi is 1. Here the pi's cancel. So the radius is 16 divided by 2, so it's 8 units long. If you have the radius, you can easily find the diameter. The radius is twice the length of the diameter, so it's 16 units. So now we can find the area, which is simply pi r squared. So it's pi times 8 squared, or simply 64 pi. So that's the area. Now let's say if you have a rectangle, and let's say the length of the rectangle is 10 and the width is 5. What is the area and what is the perimeter of the rectangle? Feel free to pause the video and find these two things. So this is the length, this is the width. This side is also the width and this is the length. The area is simply length times width. The perimeter is 2L plus 2W. So the area is going to be 10 times 5, so it's 50 square units. The perimeter is going to be 2 times 10 plus 2 times 5. 2 times 10 is 20, 2 times 5 is 10, 20 plus 10 is 30. So the perimeter is 30 units long, and the area is 50 square units. So let's say if the area is 40 units long, and let's say the length is 8 units. What is the perimeter of the rectangle? Go ahead and try that problem. So the length is 8. We don't know the width, but we could find the width by using this equation. So 40 is equal to 8 times W. So W is 40 divided by 8. So it's 5 units long. And then once you have the width, you can now find a perimeter. So it's going to be 2L plus 2W. So it's 2 times 8 plus 2 times 5. And that's 16 plus 10, which is 26. So here's a practice problem that you could try. So go ahead and take a minute and see if you can figure it out. The length of a rectangle is 3 more than twice the width. If the area is 44 square centimeters, what is the perimeter of the rectangle? So take a minute and work on that problem. So let's draw a picture. So this is the length, this is the width. Now let's write an equation. The length is 3 more, or 3 plus, twice the width. That's 2W. And we know the area is 44 square units. What is the perimeter of the rectangle? If we could find the length and the width, then we could find the perimeter. The area, we know it's length times width. And what we can do, if we want to, is we can replace L with 3 plus 2W. So we can get the area equation in terms of W alone. So we got to solve this by substitution. So 3 plus 2W times W is equal to 44. Now let's distribute W. So W times 3 is 3W. W times 2W is 2W squared. Now let's move the 44 from the left side to the right side. So 0 is equal to 2W squared plus 3W minus 44. So what we have is a trinomial, or a quadratic expression, and we need to factor it in order to find the value of W. So how can we factor this particular trinomial? What we need to do first is multiply the leading coefficient, which is 2, by the constant term, negative 44. 2 times negative 44 is negative 88. So what two numbers multiply to negative 88 but add to the middle coefficient 3? This is positive 11 and negative 8. 11 plus negative 8 adds up to 3, but they multiply to negative 88. So now what we're going to do is we're going to replace the middle term 3W with 11W and negative 8W. So it's going to be 0 is equal to 2W squared minus 8W plus 11W minus 44. I wanted to put the 11 next to the 44 because 44 is a multiple of 11, and 8 is a multiple of 2. So in the next step, we're going to factor by grouping, and that's why I've arranged it the way I did. So in the first two terms, let's take out the GCF. The greatest common factor is 2w. 2w squared divided by 2w, that's going to be w. Negative 8w divided by 2w is negative 4. In the last two terms, let's take out an 11. And let's get rid of some of this stuff over here. Actually, I'm going to need that. So let's just get rid of this. And I don't think I need this for now. So if we take out an 11, 11w divided by 11 is w. And negative 44 divided by 11, that's negative 4. So now let's factor w minus 4. When those two terms are the same, that means that you're on the right track. You've done everything correctly so far. So if we take out w minus 4 from this term, what we're going to have left over is the 2w. And if we take it out from the second term, we're going to have 11 left over, but it's going to be plus 11. So now what we need to do is set both factors, w minus 4 and 2w plus 11, equal to 0. So if we add 4 to both sides, we can see that w is equal to 4. In the other equation, we got to start by subtracting both sides by 11. So 2w is equal to negative 11. And if we divide by 2, w is negative 11 over 2. Now, we're going to get rid of the negative answer because we're dealing with a real-life object. And to have a side length of negative 5.5 doesn't make sense. So we're going to choose this value. W is equal to 4. So if w is 4, we can now find the length, which is 3 plus 2w, or 3 plus 2 times 4. So that's 3 plus 8, and that's 11. So the length is 11, and the width is 4. And we can see why the area is length times width, 4 times 11, which is 44. So that works out. Now we can find the perimeter. The perimeter is 2L plus 2W. So that's 2 times 11 plus 2 times 4. And so that's 22 plus 8, which is 30. So that's the answer to this particular problem. That's the perimeter of the rectangle. By the way, for those of you who are taking the ACT exam or the SAT exam, when you get a chance, go to YouTube and search out my ACT math video and SAT math video. You can get more examples and multiple choice practice problems if you want to practice and prepare for the math sections of those exams. I'm also going to post it at the last 20 seconds in the end of this video, so you can find the link there as well. Or you can just search it to YouTube, it should come up. But let's continue with this problem. The length of a rectangle is 3 more than its width. If the perimeter is 26, what is the area of the rectangle? So go ahead and try that problem. Now we know the perimeter is 2L plus 2W. So 26 is equal to 2L plus 2W. Now notice that we could simplify this equation. Let's divide everything by 2. So 13 is equal to L plus W. Our goal is to find the area of the rectangle. If we could find the dimensions, if we could find the length and the width, then we could easily find the area. Now we're told that the length is 3 more than its width. So L is 3 plus W. So what we're going to do at this point is replace L with 3 plus W. So 13 is equal to 3 plus W plus W. So that's 3 plus 2W. Now we can find the value of W. Let's subtract both sides by 3. So 10 is equal to 2W. And if we divide both sides by 2, 10 divided by 2 is 5. So W is 5. L is 3 more than W, so 3 plus 5 is 8. So L is 8. So we have the width and we have the length. Now we know that the area is length times width, or 8 times 5. So it's 40 square units, and that's the answer. Now let's talk about triangles. let's say if we have a right triangle, and let's say one side, one of the legs is 3 and the other leg is 4. What is the hypotenuse of the triangle? Let's call the side A, B, and C. According to the Pythagorean theorem, a squared plus b squared is equal to c squared. So we can say a is 3, b is 4, and let's find c. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So if you take the square root of 25, this will give you 5. So the length of the hypotenuse, which is the side across the 90-degree angle, represented by this box, that is 5 units long. Let's try another example. Let's say the hypotenuse is 13 units long, and one of the legs is 5. Find the missing side. Now you need to know some special numbers for a right triangle. There's the 3, 4, 5 triangle. There's the 5, 12, 13 triangle, which is the one that we need. So notice that the missing side is 12. And some other ones that you need to know is the 7, 24, 25 triangle, the 8, 15, 17 triangle. There's the 9, 40, 41 triangle, and also the 11, 60, 61 triangle. So if you know these triangles, you don't have to use the Pythagorean theorem formula. You could just simply find the missing number. But let's confirm it using Pythagorean theorem. Let's prove that this is 12. So we know that a squared plus b squared is equal to c squared. And our goal, let's say we're looking for b. So a is 5, and the hypotenuse c is 13. 5 squared is 25. 13 squared, 13 times 13 is 169. And if we subtract both sides by 25, 169 minus 25 is 144. So now we got to take the square root of 144, which is 12. So it pays to know the special right triangles. Here's another example. So let's say that the hypotenuse is 10 and one of the sides is 6. What is the missing side? Go ahead and pause the video and figure it out. So let's write the special triangles: 3, 4, 5, 5, 12, 13, 8, 15, 17, and so forth. Notice that if we take the 3, 4, 5 triangle, and if we multiply everything by 2, notice what happens. We're going to get the 6, 8, 10 triangle. So multiples of the 3, 4, 5 triangle also apply to a right triangle. Here this is 6, this is 10, the missing number is 8, so x is 8. So let's prove that. So a squared plus b squared is equal to c squared. A is 6, we're looking for b, and the hypotenuse is 10. 6 squared is 36. 10 squared is 100. 100 minus 36 is 64. And the square root of 64 will give us the missing side, which is 8. So let me give you a few examples. For all of these, find the missing side. Find the value of x. You can get started with the first example. Okay, so let's start with the first one. The first one is associated with the 7, 24, 25 triangle. Therefore, x is 25. Now for the second one, it's associated with the 8, 15, 17 triangle. We have 15 and 17, so the missing side has to be 8. Now for the third one, notice that it's proportional to the 3, 4, 5 triangle. It's not proportional to any other right triangle. So if we multiply these numbers by 3, we're going to get 2 of the numbers that we have in the triangle. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So if you see 2 sides present, then you know the third side has to be 12. The next one is simply the 9 is the 40. Actually, I messed up on this one. I meant this to be 9. It's supposed to be the 9, 40, 41, but I got mixed up with the 11, 60, 61, so that's a bad problem. Ignore it. Now the next one is associated with the 5, 12, 13 triangle. If we multiply those numbers by 2, it's going to be 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. So we have 2 of these numbers, 10 and 26. So the missing side has to be 24. Now for the last one, let me redraw it because of all the clutter. This is 30, 40, and we're looking for x. Notice that this is similar to the 3, 4, 5 triangle. So if we multiply 3 by 10, we get 30. 4 by 10, 40. So 5 times 10 is 50. So that hypotenuse is 50. Here's another problem that you could try. A rectangle ABCD, AB is 12 units long and AC is 13 units long. What is the area of the rectangle? Now rectangles, they form 90-degree angles. And look at the triangle that forms. We have a right triangle. If this is 12 and that's 13, what is the missing side? So we know this is the 5, 12, 13 triangle. So length BC is 5. So now we can find the area. The area of the rectangle is length times width. The length is 12, the width is 5. So it's just 12 times 5, which is 60. So as you can see, you can find the answer quickly if you know your special right triangles. You don't have to use the Pythagorean Theorem formula. If you commit this to memory, it will save you a lot of time. And on the SAT test and on the ACT test, time is a factor. So you want to find the answer quickly. Number 4, triangle ABC is a right triangle, and O is the center of the circle. If AB is 12 and BC is 16, what is the area of the circle? So go ahead and take a minute and try this problem. So what we have is a right triangle, and we know that AB is 12, BC is 16. Now, if O is the center of the circle, that means segment AC is the diameter of the circle because it passes through the center, and it connects one edge of the circle to the other edge. Now, our goal is to find the area. The area is pi r squared. If we could find the diameter, we could find the radius, and thus the area. So we got to find the third side of that triangle. So it's 12, 16, and what is the missing number? Notice that this is related to the 3, 4, 5 triangle. If you multiply these numbers by 4, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So we got the first two numbers, and the third number must be 20. So 20 is the hypotenuse of the right triangle, which is the diameter of the circle. So therefore the radius, which is half of 20, the radius must be 10. And so the area, which is pi r squared, that's pi times 10 squared. 10 squared is 100, so the area is 100 pi, or about 314 point something. So this is the answer to the problem. Now the next thing that we need to calculate is the area of a right triangle. So let's say that the hypotenuse has a length of 25 and the base is 7. Find the area. So first we need to know what the formula is. This is the base of the triangle and this is the height. The area is simply 1/2 the base times the height. So all we got to do is plug it in. We have the base. The base is 7 units long, but we need to find the height. So what kind of right triangle do we have? This is the 7 what? 25 triangle. We know the missing number is 24. It's the 7, 24, 25 triangle. So then we have the height. So now we just got to do the math. Half of 24 is 12. So the area is going to be 12 times 7. So what's 12 times 7? 10 times 7 is 70. 2 times 7 is 14. 70 plus 14 is 84. So 84 is the area of the triangle. Here's another problem. So consider this triangle. Let's say this side is 15 and this is 13, and the height, let's say, is 12. So basically, that is the distance between these 2 points. Go ahead and calculate the area of the triangle. So take a minute, pause the video, and work on this example. So let's draw a straight line. So that line is perpendicular to the base of the triangle. So what we can do is make 2 triangles. So the one on the left has a hypotenuse of 15 and a height of 12. What's the missing side? So if you see 15 and 12, know that it's associated with the 3, 4, 5 triangle. If you multiply 3 by 3, you get 9. 4 times 3 is 12. 5 times 3 is 15. So this is the 9, 12, 15 triangle. Now let's draw the other portion of the triangle. So this has a hypotenuse of 13. The height is still 12. They share the same height. What triangle is this? So this is the 5, 12, 13 triangle. The missing side is 5. So therefore, the length of the base for the entire triangle is 9 plus 5, which is 14. So now we can find the area of the triangle. The area is 1/2 base times height. So the base is 14 and the height is 12. Half of 14 is 7, and we know 7 times 12 is 84. So that's the area of this triangle. Now here's another problem. Let's say this side is 10, this side is 8, and the angle between those 2 sides is 30. What is the area of the triangle? Now, we don't have the height of the triangle, so therefore we should use another formula. If you have 2 sides and the angle between the 2 sides, you can use this formula. Area is 1/2 AB sine of C. So what is AB and what is C? Well, let's draw a regular triangle. So the capital letters is associated with the angles. So this is angle C, angle A, angle B. The lowercase letters are the sides across that angle. So across angle C, we have side C. Across angle A, we have side A. And across angle B, we have side B. So let's say if this is angle C, this is angle A, this is angle B. That means angle C is 30, side A is 8, side B is 10. So to use the formula, it's going to be 1/2 8 times 10 sine of 30 degrees. Half of 8 is 4, and sine 30 is also 1/2. 4 times 10 is 40, and half of 40 is 20. So that's the answer. Now let's work on another example. Let's say if we're given this triangle, and this side is 8, this is 9, and this is 10. So this time we don't have 2 sides and the included angle, but we're given all 3 sides. How can we find the area of the triangle under these circumstances? We need to use Heron's formula. The first thing we need to do is find S, which is 1/2 of the perimeter of the triangle. The perimeter is A plus B plus C, so it's half of that. So it's going to be 8 plus 9 plus 10 divided by 2. 8 plus 9 is 17 17 plus 10 is 27. And 27 divided by 2 is 13.5. So that is S. That's how we could find it. And now let's calculate the area. So the area is simply the square root of S times S minus A times S minus B times S minus C. So S is 13.5. And then it's going to be 13.5 minus 8 times 13.5 minus 9 times 13.5 minus 10. So I'm going to take one step at a time to get the answer. So 13.5 minus 8. But we know that 13 minus 8 is 5. So 13.5 minus 8 is 5.5. 13 minus 9 is 4. So 13.5 minus 9 is 4.5. And 13.5 minus 10 is 3.5. So let's multiply 13.5 times 5.5 times 4.5 times 3.5. So you should get 1169.4375. And the square root of that number is about 34.2 rounded to the nearest tenth. So this is the area of the triangle. Now let's say if we have an equilateral triangle and we're given one of the sides, let's say it's 8. What is the area of this triangle? In an equilateral triangle, all sides are equal. So that means the length of each side is 8. It's also an equal angular triangle. The angles are all 60 degrees. If the sides are the same, then the angles should be the same. So, what is the area of an equilateral triangle? The area is root 3 divided by 4, s squared, where s is the length of one of the sides, or all of the sides. So it's just going to be the square root of 3 divided by 4 times 8 squared. 8 squared is 64. And 64 divided by 4 is 16. So the answer is 16 times root 3. Or as a decimal, it's about 27.71 rounded to nearest 100th place. So that's it. So make sure you know this formula anytime you come across an equilateral triangle. And if you need to find an area, it's very useful. Now let's say if you have a triangle with a base of 6 and a height of 9. And also you have another triangle, a similar triangle, with a base of 15. What is the height of that triangle if these are similar triangles? If you ever get a question like this, the best way to solve it is to use a proportion. So let's call this triangle 1 and triangle 2. So we're going to write two fractions and set them equal to each other. So the fraction on the left is associated with triangle 1, and the fraction on the right is for triangle 2. Now let's put the height on top and the base. So the height of triangle 1 is 9, the height of triangle 2 is x. The base of triangle 1 is 6, and the base of triangle 2 is 15. So now all we need to do is find the value of x. To do so, we can cross multiply. 6 times x is 6x, and that's equal to 9 times 15. Now we can multiply 9 times 15, or we could just leave it the way it is. I prefer to leave it the way it is, and you'll see why in a minute. 6 is basically 3 times 2. 9 is 3 times 3. 15 is 5 times 3. At best, we can cancel a 3 and then divide both sides by 2. So x is going to be 3 times 3, which is 9, and 9 times 5 is 45. 45 divided by 2 Well, 44 divided by 2 is 22, and 1 divided by 2 is half, so this is 22.5. So that's the length of the missing side, is 22.5. 9 divided by 6 is 1.5, and 22.5 divided by 15 is also 1.5. So they have the same ratio, which is a characteristic of similar triangles. An 18-foot streetlight casts a shadow on a 6-foot man, as shown in the figure below. If the man stands 5 feet away from the base of the streetlight, how long is the length of the shadow? So the streetlight is 18 feet high, and the man is 6 feet tall. Now the man stands 5 feet away from the streetlight, so this distance is 5. Our goal is to find the length of the shadow, which is between these 2 points. So feel free to pause the video and find the value of s. The best way to do this is to draw 2 similar triangles. So let's start with the small triangle. So we have s, which is the length of the shadow, that's the base of the small triangle, and the height of the man, which is 6. So basically that's this triangle right here. Now let's draw the larger triangle, which involves the streetlight. So the streetlight has the height of 18, and the length of the base is 5 plus s. So let's call this triangle 1 and triangle 2. So let's set up the proportion. So we got T1, T2, and just like before, we're going to put the height of the triangles on top and the base on the bottom. So the height of triangle 1 is 18, and the height of triangle 2 is 6. The base of triangle 1 is 5 plus s, and the base of triangle 2 is simply s. So let's cross multiply. So we got 18 times s, and then 6 times 5 plus s, but we need to distribute. 6 times 5 is 30, and then we got 6 times s, which is 6s. So now let's subtract both sides by 6s. So 12s is equal to 30. So now let's get rid of a few things. So s is 30 divided by 12. Now let's reduce the fractions. 30 is 6 times 5. 12 is 6 times 2. So we can cancel a 6. So therefore s is 5 divided by 2, or 2.5. So now let's double check the work that we have. Let's make sure that the ratio between the base and the height is the same. So for the first triangle, this is 18 and this is 6. And for the second triangle, this is 2.5. And this is going to be 5 plus 2.5, which is 7.5. The length of the shadow was s, that's 2.5, and the person was 5 feet away from the street light. So therefore, the length of the entire triangle is 5 plus s, or 7.5. So 18 divided by 7.5, does that have the same ratio as 6 over 2.5? 18 divided by 7.5 is 2.4. And 6 divided by 2.5 is also 2.4. So we know that this answer is correct. The ratio between the base and the height of these two triangles are the same, which means that they're similar. It's a quick and simple way to double check your math to make sure that your answer is correct. The next thing that we need to go over is the 45, 45, 90 triangle. Now this is of course a right triangle. Across the 45-degree angles, the sides are 1. And across the 90, it's root 2, or 1 times root 2. Now why is this useful? Sometimes you might have one side and an angle, and knowing this special right triangle, you can quickly find the other two sides. Now here's something you want to know. let's say if you have the side across the 45-degree angle and you wish to find the side across the 90-degree angle, multiply by root 2. And if you have the side across the 90, and if you want to find the side across the 45, divide. Because the side across the 45 is smaller than the side across the 90. So for example, let's say that this side is 8, and you know this angle is 45. What are the other two sides? Well, this is 45 as well, which means that these two sides are the same. So therefore, this side is 8. Now, to find the hypotenuse, using this side, you simply multiply 8 by root 2. So it's 8 root 2. Now, let's say if we're given the hypotenuse, let's say it's 10 root 2. And you want to find the side across the 45-degree angle. So because you're looking for a shorter side, you need to divide by root 2. 10 root 2 divided by root 2 is simply 10. So these two sides are 10. So here's another example. Try these two problems. So let's say this is 45 and this side is 12. Find the missing sides. And let's say this is 45 and you're given the hypotenuse. Let's say the hypotenuse is 9 root 2. Find the missing sides. So for the first example, we know this is 45 degrees, so this side has to be 12. To find the side across the 90, you multiply 12 by root 2. Now for the other one, to find the sides across the 45, you divide the hypotenuse by root 2. So this is going to be 9 and 9. Pretty straightforward, right? Well, let's try this one. Let's say if the hypotenuse is 7, and this is 45 degrees. Find the two missing sides. And let's say that this side is 5 root 2, and the angle is 45 across it. Find the other sides. Well, to find the side across the 45-degree angle, given the side across the 90, the hypotenuse, you need to divide by root 2. So this is going to be 7 divided by root 2. If you want to, you could rationalize it. Sometimes you don't have to. But if you want to rationalize it, it's 7 root 2 divided by 2. Now in the next example, we know that these two sides are the same, so this is 5 root 2. To find the side across the 90, we got to multiply 5 root 2 by root 2. Root 2 times root 2 is the square root of 4, and the square root of 4 is 2, which is 5 times 2 is 10.